All right, I will give folks a few minutes to join and then get started. All right, so I'm going to go ahead and get started. I don't know the delay of the Hangout live chat versus the Hangout on air, so we'll just make the best of it as we go. So this is a seminar on the Open mHealth use case scenario to try to get a little bit more specific in the design discussion, and as a result, hopefully to generate some design ideas from the other folks that are working on either components of the system or are interested in seeing how it impacts their research. So it's somewhat hastily assembled, so I apologize for that. The intent is to recap the NDN exercise application, to fill you in on some progress and work so far, propose a data namespace and identity design, and suggest an initial application architecture that hopefully will generate more detailed design proposals by others. And then also, I'd at the end maybe like to talk through even via the chat and get some feedback on how we can collaborate together. So this talk assumes that one has read or listened to the initial Open mHealth presentations and read the related documents. So the Dropbox links are below. I don't know that that'll do you any good in the. I don't know that that'll do you any good in the way that this is being displayed, but these are all things that people have seen before, and then I'll distribute these slides so that you have the links. Audience for this is the general NDN project team, and sort of asking the question, how can the research that you're interested in be connected to the network environments like this one, and then specifically to the collaborators on the NDN Open mHealth application, how can we kind of pivot towards more active group development? Okay, so some of this will be recap and some of it will be new. This is so NDNX, for lack of a better name, we're maybe working on a better name, is a physical activity monitoring application, a lot like a number of other apps out there for gathering data on your physical activity and providing it back to you so that you can improve your health, manage running and jogging and walking collaborations with friends and so on. And this is actually a pretty significant commercial area and a pretty important area for dealing with chronic health issues. We're not going to focus too much on the motivation today. And a little bit of an aside, that our objective for this network environment is not only to build a sample application, but to build an example of interoperating components of an Open mHealth ecosystem. And this places some additional requirements on the design that are not just about let's get the app up quickly, but let's at least get it up quickly in a format that probes at some of the questions about an ecosystem of design. So I would encourage you to read. It's a 2-page paper that Estrin and Sim paper on OpenM Health and maybe watch Deborah Estrin's short talk on small data, just to get a sense of some of the ideas that are floating around and driving the OpenM Health ideas. So we're talking about an application that gathers, stores, calculates, and reports activity metrics of physical activity, so running, jogging, walking, based on GPS and accelerometer data, so stuff that you can get from a regular mobile phone. And both potentially for automatically and self-identified bouts or rounds of exercise and in teams. We're also interested in something that would do location-based content push during the exercise, which could be for health, culture, entertainment, local, team-related content. So a little bit of bidirectional communication with the recording device. There are some commercial parallels in systems you've probably heard of. All right, so what's the end user data collector perspective on this application? So somebody, and this is a rough cut, I think, but relatively straightforward. So somebody downloads and installs a mobile activity capture application on Android, our initial platform of focus. You visit a website to join the service and make a choice to link to a particular storage provider or create a new storage or publishing account. And that storage provider is providing storage for your physical activity data. And this may be different than the visualization provider or the application provider. And this is really the one sort of nod that we're going to make towards the idea of an ecosystem, that the process that is visualizing is different from the process that is public, or the owner of the visualization is different from the owner of the storage application. You might get to pick intermediate processing steps. We'll talk about this a little bit later. You need to somehow link the mobile application to the identity on these services. And then we're imagining that you would explicitly start this application during exercise. There are some alternatives to that, but it's probably most realistic for battery usage. Most realistic for battery usage if we do this just for specific bouts of exercise. After you stop the exercise, you visit the website to track progress, look at historical comparisons, organize exercise set preferences, and so on. And we'll see how far we get in implementing the actual end user application. We have to do enough that we can generate some trials and some data. So we're doing some initial work on a very sort of clean user interface design that includes both content push, recording of walks, and then we'll also have an end user website. We want to be able to provide to the end users also some insight into what's going on in the system, and so eventually we'll be looking at how do we represent choices about data processing and choices about identity. So that's a quick cut at the user perspective. What's the design perspective? Folks have probably seen a version of this diagram before, all the way back from the NDN proposal. Again, the idea is there's a number of services in an ecosystem that take mobile data collection on the left and result in feedback either on a mobile device or on a web-based user interface. And this is the perspective of sort of the developer in terms of the ecosystem of components. Notice many of the data sources are mobile, and that's important. This is a specifically selected driver for certain kinds of problems that we want to tackle in research, and one of those problems is the mobile publisher scenario, where I might want to publish into the same namespace from multiple places in the topology. I'm not going to go into that in detail, just to mention that's one of the challenges that's motivated. Also, from the design perspective, though, the thing that we want to focus on is data-centric interoperability, that we're really not trying to focus on a number of composable services that talk through REST-style interfaces to different function calls, but rather you could almost think of it as a giant tuple store, or a giant, I think tuple store might be the best analogy, but a giant sort of network storage approach that takes in named data, consumes it, processes it, generates new named data, and that data follows namespace and format data payload conventions that allow us to create interoperability between components rather than composing services. And so there's all kinds of Hangout windows popping up on my screen now. And okay, and so just a quick kind of comparison to elaborate on this notion of what the existing model for the application is versus what we want to focus on. And this is really to consider some initial design requirements and get to that point where we can talk about what the application design might look like. So the things that we want to keep are an emphasis on data-centric rather than service-centric interoperability that I mentioned, the distributed architecture of capture, data storage units, data processing units, data visualization units, which are kind of abstract concepts in the OpenM Health ecosystem that you can read more about on their website or from some of the papers that are mentioned. It's also an end user focus. So if you're just joining the call, please turn your video and audio off on the Hangouts. We'll try to use chat there. Looks like there is a participant maximum on the chat for Hangouts that I don't know what to do about while we're going, but hopefully if you hear something and you want to ask a question, you can get into the group chat. If not, I guess we'll have to sort it out next time, or maybe you can send me an email and I'll try to look at emails at the end. Okay, and so the end user focus means this is really specifically about, now there is another chat window. Okay. The end user focus means we're not looking at electronic health records, we're not looking at hospitals and doctors and communications between patients and doctors, we're really looking at things that are happening in the consumer market around end user fitness applications in this particular little slice of the work. We want a user-centric approach to privacy, which means we want people to know what options are available to them and what the system is doing with their data in terms of either privacy protections or options that they might have. Then we are expecting that all communications would be encrypted and that we keep this is part of the existing Homage architecture, and that we would have mobile publishing, that the bulk of the data is actually coming from mobile devices. Things that we want to move away from are the kind of REST and HTTP-based RPC call model, and even the notion of replicating that by carrying state and interest, and try to get actually to this data dissemination focused model. We don't want to have host-based endpoints for services, period. We'll focus on data dissemination and NFN style processing. We want to move from OAuth 2, which had been used in Homage for communication across components, and try to do something that's a little bit more suited to NDN and may relieve some of the developer pain around OAuth 2. And we want to get rid of the notion of centralized storage to some extent, at least as we evolve. And so what this might mean is that we do need to, of course, focus on data namespace design. Want to look at how we implement a data flow approach to this architecture of components in NDN. Focus again on consumer app deployment. Inform the user of the choices. Figure out how we can be efficient with encrypted communication and still take advantage of caching in some cases. And we have a real driver that we need to solve mobile publishing for. And so a few more design requirements. The data format namespace design should come directly from the OpenM Health developer documentation. I'll link to that in a second. They have an existing data schema. We are going to see if we can follow that as best we can. Maybe we'll extend it a little bit. The identity and trust management scenario really needs to come from the proposed application use case. And that this is not just an app, it's an example of interoperating components in an ecosystem. And then finally, that the application architecture should come from the requirements above and from previous participatory sensing projects, which was a focus of initial work in NDN FIA, but there are some pretty relevant papers that have been distributed previously. Okay, so what's the basis of design that I'm proposing for the data namespace? This is a link to the physical activity schemas. I'm not going to visit it right now. You to be aware that if you go to OpenM Health and look at the developer documentation, that there are specific schemas for the type of physical activity that we are going to do. So these are JSON schemas, and they represent generally already classified activities. So something where the record is not a bag of GPS points as somebody is walking in a time location trace. It's actually a classified piece of data that says, I walked for 1.5 miles at a moderate pace at this time of day. And those are things that that data is coming out actually of the Homage client application with that classification attached to it. So to really dive into the namespace design, we want to have this general physical activity schema and maybe some other schemas from their library in mind, which gives us a data format that may suggest some name components in addition to the data itself. And then we also want to go back and look at the Homage application and kind of pull apart how it's communicating right now. We'll talk more about the progress on that so far. And then finally, the OpenM Health schemas are generally motivated by nomenclature and data schemas that are coming from larger biomedical and medical ontologies. And so I provided a link that you'll be able to click on when I distribute the actual slide deck and take a look at that. But we have a basis of design for the data namespace. So what are some requirements that seem to exist in this application for publishing? On the publishing side, we want to be able to provide both raw time location data. So this is a time series of GPS and accelerometer readings from the phone, and then support successive rounds of processing on that data that do things like generate activity classification. So things like going from that GPS trace to I've been walking for this long at this level of activity, and fit that physical activity schema that I mentioned a second ago. We want to be able to segment physical activity and exercise, and then identify those segments and add features that could be things like, were we on a road? What was the kind of activity? Can we somehow drill down into the nature of the activity? And these are all done by running classifiers and similar sort of machine learning algorithms or signal processing routines that are applied to that raw data. So the general idea in this ecosystem is people publish raw time location traces or raw physical activity traces, and then those things are subsequently processed and returned into the data ecosystem for use by other components or by the visualization component. Now, in the reference application, which is called Homage and has this Android client-side application that has a supplemental application called Mobility, so Homage Mobility, generates already activity classified data. And so it may be that even at the level of the mobile device, we have multiple types of data that are being published, and both the raw traces and activity classified traces. But in general, the idea is that there are a number of different components at different places in this ecosystem that are taking data that exists, processing it, republishing it, and then other data services are consuming that. Okay, second set of requirements, we do want to provide granular access control over the various components of the data namespace. In particular, over raw location data, we want to be really careful with that, but really over all the different types of data that are available. And what do we mean by granular? That might be data that's restricted by time, that's restricted by location, that's restricted by type, by accessing service, and so on. And so, you know, we'll probably have to balance not wanting to overcomplicate an initial design and implementation with the desire to really come up with ways that allow us to define in a granular way the groups of services or the groups of consumers that are able to access our data and to republish it. We may want to consider name encryption, at least just conceptually, to try to see whether we think it's important and useful to mask data names and avoid data leakage that way. We need to support mobile publishers in our conceptualization of the namespace, and we need ways to keep track of what keys are used to encrypt the data in a way that publishers can access them easily and not just consumers. Okay, so what are some potential requirements for the consumers? And who are the consumers in this ecosystem? So consumers are intermediate processing components. They could be repos or storage devices that are designed to replicate or republish data on behalf of a user. Or they could be the visualization or application components that need to consume data in order to present it through a user interface. And so what do these consumers need to do? It's fairly straightforward. They need to access raw and process data for certain time periods. That may mean being able to access data covering the same time period from different parts of the namespace. Straightforward, but a requirement. They need to efficiently read sequences of data, and of course access the necessary keys to decrypt the data, among many other things, of course, that need to be in the data namespace. So the first two are analogous to NDN video in some sense, where we implemented a namespace for seeking to quickly find a particular time, and also a namespace for playback that was focused on sequential playback. And perhaps this is common for many time series storage applications, also like building management and building automation. This is something to look at. So this is a very quickly written namespace based on some of the ideas to at least prompt discussion and start to think about what might be involved in this system. And the dot file that generated this, which I'm hesitant to post, will be linked in the slides when you get them, and you can go back and take a look. And it's a really ugly dot file, so please don't judge me based on that, but try to lay out a little bit of what the namespace might look like. So I'm going to break down the idea so that hopefully other folks can take a look at it relative to the application requirements and sort of tear it apart and generate new ideas on what the data namespace might look like. So this is conceptualized in terms of a per user route, where really the user that's publishing the data is the root of the data namespace, and then within it, for this application, may have the actual data under the samples namespace, authorizations that provide different ways to access the keys that can be used to decrypt that data. So talk about that in a moment. Configuration information that we won't talk about right now. Maybe some notion of caching the results to queries that are expensive to execute directly. And then certificates that are related to the user's use of the ecosystem, or at least this part of the ecosystem. Again, the user root, I'm hand waving around a little bit that this could be in any number of root locations, a publishing namespace provided by an ISP, which would have one set of considerations, a publishing namespace provided by an application provider, and all of these things have different implications. I think in some case, the immediate challenge is really how do we handle, again, mobile publishing, where the device that's publishing into this namespace is getting connectivity potentially in many different places and many different over many different networks. Okay, so to dive a little bit into the actual data for a moment, here the suggestion is that we start by separating two different types of data, raw and classified data. I think that ultimately the schema for different types of physical activity data might be more sophisticated. And so I don't know that these are exactly the right high-level categories, but these are two that we're working with in an initial implementation, one of which is a raw stream of time location data that I'm suggesting has a start timestamp component that allows us to express which starting timestamp that we want to get for a given piece of data, similar to the way that NDN video works. You can use exclusions and other selectors to guide you to the closest timestamp relative to the closest timestamp to your interest. And then I'm suggesting putting the ending timestamp in the name so that it's quick and easy to get without actually having the data packet what range of times this particular data might represent, and then actually to have potentially segmented data that represents the time location record in JSON in a format that we come up with. And so that means that there actually could be several packets corresponding to individual segments of a longer record, and give the application some flexibility in terms of how big when they start segmenting, what the start and end timestamps are, and have essentially each component in the ecosystem support any of the possible values for this, so that the publisher really can use its discretion for how to bundle data together. Under the classified section, with sort of an eye to the previous requirements for the consumer, suggesting two different namespaces, one that's based on time and one that's based on sequential segments representing bouts of activity that have either been divided just based on their sequence, or have been divided based on something actually happening in the data. So there's some discussion about where are these segment boundaries drawn, and the start and ending timestamp actually link back to bouts of activity data. So this is a segment where I'm walking, this is a segment where I'm driving, and so on. And so the suggested namespace for the left hand, it would be the center column of this namespace, is that there's some kind of sequence number, a segment index, a activity name like walking, biking, running, or so on, that corresponds to the type of activity that was classified, and then start and end timestamps, followed by a bundle of activity data in the format that's recommended by the OpenM Health data schema. So this is a kind of an, I think will be an ongoing question for us, which is how do we pull from the data schemas that are out there and decide what goes in the name versus what goes in the record and what's in both places and so on, or what's in the payload rather. And so the suggestion here is that the activity name and the start and end timestamp are potentially useful in deciding what interests to issue to get a certain kind of data, and so maybe we should see those things in the name. This is, I think, an open area for discussion. So what do we do about key exchange? And so this is something that is, again, just a very quick straw man to provoke discussion, but both the consumers and the publishers need ways to access the keys that they're using to get decrypt the data that's been published in the namespace that you just saw. And so the proposal here is that each consumer would have access, in the left-hand side of the namespace here, would have access to a decryption key for different chunks of data, probably missing in the name actually something that describes the chunk, but I'll explain that in a second. And so a reader, a consumer of the data, would request a token, request a unique decryption key or a unique identifier from some authorization service, and maybe there's a way that we can implement that just through data exchange. And that would be a way for the consumer to issue an interest for that, using that token in the name, for a key that would allow them to decrypt the chunk of data that they're interested in. And that key might be something that's shared among multiple consumers. It might be something that's unique to that particular consumer. And the proposal is, by having this sort of tokenized index of encrypted keys that are used to decrypt the data, we have some flexibility in designing what the granularity and what the exact who gets to use what key and what it applies to. And maybe there's some more work that needs to be done in this. My thought was that exposing information about what the decryption key decrypted was not necessarily something that we would want to do in the name, but I think that's open maybe for discussion. And then that there might actually be a different indexing scheme for the publisher as to what keys are being used. And so I'm less sure about what the scheme is on the right, but it's just to suggest that probably the mechanism by which the reader accesses keys may not be the same as the way that the publisher may efficiently want to get to them. Don't know the answer to that. Now, so what does identity mean in this application? And identity being the basis of being able to access, for example, encrypted keys that are used to get at particular chunks of the data. And so the only takeaway I think that is important for right now is that I think the identity of a user is probably different as a publisher of the data versus as an application user, and that just being a start at thinking about an ecosystem of components where the legal entity or the service provider that provides the service of data publishing is not necessarily the same one that provides the consumption. And so a user may have an identity for physical activity data publishing that's different from their identity for consuming it in a particular application. And that's what this chunk of the namespace is suggesting. And we could maybe talk about the implications of that as we go. And then certainly there's an opportunity to generate derived keys that are of lower value than high value user level application keys. I don't show that here, but I think that's of course something we've talked about many times and might eventually be in part of the design, but doesn't seem to be particularly critical yet. So what's the big picture goal again? Can we or should we support different identities relative to each part of the system? And by different identities, I mean that the user's identity is not necessarily the same at the collection and publishing point as the visualization point. A question that all this makes me think about is, how much of a risk is walking around these trees and looking at what's stored in them to figure out what a given user is doing or what kind of keys are available and so on, or more so maybe even what data is available. Okay, so that was the data. Remember that the data namespace, and by extension the things that we need in terms of keys and certificates, are really the source of interoperability in this ecosystem. They are the thin waist. not just in the NDN sense, but in the application sense. And this image that I keep putting up is from the Esther and Sim paper in 2010 on the OpenM health concept. Okay. Remember, there's also, though, this app architecture and ecosystem. So what does that look like? In some sense, if you tip this hourglass over and aren't really too concerned with it being totally accurate, the app architecture that was drawn earlier suggests that sort of same ecosystem. So in the middle, or kind of to the left, is the repository of data or the set of repositories that form the thin waste of data exchange, or at least are providing the storage for it, let's say. And then a series of processing components in blue and visualization components in green. And the origin of all this data, though, is from the mobile capture using a particular software called Homage on Android. Where does this come from? So I have two references that I think are critical for people to read in order to understand practically where we're starting, and then conceptually where some of these ideas come from. The first is a 2014 paper on Homage that actually wasn't out, I think, originally when we proposed the network environment. Provides a great summary for the TCP/IP version of this reference application that's been used in over 20 field trials of all different kinds, not all about physical activity, but some. And then also a participatory sensing application called the Personal Environmental Impact Report that actually follows a similar, an analogous version of this processing chain, but to generate different kinds of data. All right, and as you've seen before, probably in other slide decks and other conversations, we've been trying to distribute work in these areas, even if this exact architecture doesn't stay the same, that there are a number of different people, a number of different groups working on this. It should say IRL at UCLA instead of CLU. I think that's it's an internal name or something like that, but the IRL at UCLA, and then the other institutions that are shown here. Okay, so I'm going to recap each of these components and give you a little bit of progress, because I think they relate very practically to some of the questions that have come up. So our starting point for data capture is the Homage mobile application, which is available on both Android and iPhone, but we're going to focus on the Android version. It requires something called mobility, which is a module that generates physical or captures physical activity in the background. The paper that I cited in an earlier slide is really the one to look at to get an overview of Homage, both on the mobile application side and the server side and visualization components. And so what is our activity? And the sort of practical activity is to port Homage and mobility to NDN and focus on the original requirements of their design plus our kind of end user requirements from an exercise application. And you've seen this slide before, and it has some requirements about what Homage does, so I'm not going to dwell on that. And again, the point is to take the existing application, look at how we can start having it store and communicate data using NDN instead of using its existing REST-based approach. So what's going on with this? We have an instance of the TCP/IP Homage version, both the client and server, up and running thanks to Haitao and Lisha's group at UCLA. And I'd love to get people that are interested in just trying to understand how the application works to get an account on the system, run the mobile client, generate some data, and look at how it's visualized, and maybe run Wireshark or something and look at what the data is that's going back and forth, or go through the developer documentation and see how this running reference application works. This is the thing that we're going to pull apart and insert NDN into the middle of it to some extent. There's also been an initial analysis of the Homage mobile client and the way that it communicates. This is a PDF document that we'll share shortly from Professor Jung's group at Anyang University, and where we're now beginning to really think, how can we work with this particular piece of software? Fortunately, it looks modular enough that we can do it. We had some updates from Basel University in Switzerland, which looks like they're actually using Homage in some pilots in the psychology department. And so Christian Schuden's group there, that's looking at the intermediate processing, is talking with them, and I think has some ideas on how we might learn from their deployment experience. So we have at Basel, at UCLA, at Cornell, where Deborah Estrin is, experience in using this in real field trials. And so if people are at the point where they want feedback on that, we'll get together with some of these groups. Okay, storage. So the model for storage started out as a notion of a personal data repository, and I have 2 links here to papers that you can read for some background on the notion of a personal data repository. I think this has matured into an idea that there are multiple points of storage in the network that are all responsible for this physical activity data for an individual, both the original data and the data that's generated from subsequent sets of processing. So really, instead of thinking of the homage concept of a centralized storage, we're trying to broaden the notion of where storage exists based on the capabilities of NDN. So on the mobile device, at some kind of repository that's distributed, and then probably as a cache at the inputs, persistent cache at the semi-persistent cache, I guess, at the input to each of these processing components. And so what are we doing for storage? The proposal is that we need 1 or more new repo designs, and that we need to move from a cloud storage model to something that is really focused on distributed in-network storage at a variety of points in the system. So we're not going to directly port the homage approach to storage, which is essentially I believe it was a SQL store for a while. I'm not sure exactly what it is now. Now I'm proposing at least a hierarchical design of repositories in the ecosystem that includes storage at the mobile device itself for disruption tolerance, for example, a data repository, which is a warehouse for an individual's physical activity data that may be distributed among multiple repos in the network, and then some approach to temporary storage for processing and visualization components. Nothing earth-shattering here, but just a notion that there is a sort of hierarchy with the mobile device being the point of generation, but this distributed data repository as the upper level kind of canonical place to go for location for the NDNX data. The current plan is to implement this in Java using JNDN so that we can provide Android support through the same code base that's supporting the server side or cloud-based repositories. And this is a design being led at Tsinghua, and I'd love to at some point try to create a conversation with IRL, with the security folks, and with Tsinghua to talk about what the repo design might look like and get us moving on that. So then the intermediate processing. So these are components that are, in some sense, might be optional or might not. And as I mentioned, some of these exist already in Homage and others don't. And they are used by the visualization or end user interface components on the right. And they may be selectively applied by the users. And so we have a couple different examples here. I'm not sure that we'll stick exactly with these examples. Geofencing and location-based notification seems to be one that we will. Activity classification, location anonymization, these are things that may be supplanted by other ideas for what intermediate processing could be. The idea, though, is to have some kind of composable data flow model that's inspired by Apache Spark or Google Cloud Dataflow or something where you have composable services that have been authenticated in a way that they can access data from services preceding them in the chain. And it would be nice to see if we could provide an approach to this using the named function networking style approach coming out of the University of Basel. And so they're thinking about this. My thought is to start with geofencing because we know that we need that, and activity classification, at least at some level, was already handled in Homage, and maybe we don't need to do that initially. I have some links in this presentation and things that people have seen before on each of these potential types of processing. I'm not going to go through them right now. Quickly on geofencing, the general idea is to prevent service activation or data access out of a location boundary. We can also use it to generate location-based triggers. It's a similar concept. This idea of running continuous nearest neighbor queries on incoming location data is pretty intriguing because it creates a need for a low latency path for data to flow from the mobile device. So we might have one path for the data that is going through activity classification, takes a little bit more time, or is done and published in a different way. And this may take as its input time location data that has different access controls on it, that has different data format, and that's generated by a need for that data in other parts of the application. Okay, so again, the approach is to look at the named function networking concept. I'm not going to cover this in detail here, but the idea that names serve to access and invoke processing functions and generate content that then is passed off to other parts of the chain. And so how to implement this whole thing in a way that's done in a kind of NDN-like way, where the initiation of the pull is happening at the client side or the user interface side, pulls this data through, I think is a good model for us to look at. The data processing unit is a specific notion that has been discussed to some extent in the OpenM Health reference applications, but I think is largely conceptual there, as these tend to be on the servers that are receiving the data and not necessarily on separate machines, but possibly they are. And in the personal environmental impact report project that I mentioned earlier, this type of processing chain exists there as well. All right, just quickly, I wanted to hit some highlights from a recent email update from the University of Basel on these components, in particular some of the middle ones that have to do with starting to provide implementations of NFN that can be accessed through the NDN testbed. And then the second to last bullet, the idea of focusing on RESTful logic in NFN. I have not written back to Christian yet, but maybe he's listening, although I guess it's pretty late there. I'm not sure about REST. I think that the idea that having this kind of RPC call style mechanism may not be exactly the right analogy for what we want to do in NDN, but in any case, there's certainly the notion of distributed functions processing this data that's pulled through from the need of the consumer is something that we can do. They are starting work on how to handle access control, which I think is going to be a great area of interest and maybe overlap with other groups on our team, and something that we should focus on. And that's the last bullet. Okay, and then we are going to build some end user visualization components over time. I have some links. Some links to this that once we start developing these designs, we'll share them with folks. I think they're going to be things that you can imagine pretty well as fitness and activity monitoring types of applications that you may have seen before. There is a project I think that's worth looking at called Life Streams, which is a kind of modular approach to identifying patterns that are coming from everyday data. And this is a more general point of reference for the OpenM Health application. And I'm going to keep pointing as much as I can to these higher level general references to mobile health application concepts, and really encourage you to, and all of us, to read these and frame our thinking about based on these papers that are trying to set an agenda for a new area of research in terms of mobile health. And we're going to leverage the pre-existing components. I'll talk more about this, I think, when we're able to give specific examples of the types of visualizations that we would like to do. We do want to, like I said, generate location-based content emission. We have some work on mobile websites and applications that do this already, and we're doing it for cultural content, so we'll probably do something similar using a park that we've been working at and developing new applications for with California State Parks around actually access to historical and cultural content during exercise. So we'll try to do a mixture of these applications. So I do want to kind of leave you with some questions about identity in particular. Really, what are the different notions of identity that exist in different places in the system, are to me one of the key questions that we have to answer, in addition to what the data itself looks like. And then I really also want to ask about how do we step into an active group development process and start working out design alternatives. Hopefully you've seen holes or things that exist in this sketch of both namespace design, some ideas on what identity might look like in the namespace, how the components go together, and we can progress from that to enough of a blueprint for design that all of the groups that are working on implementing components can essentially start, and then we can flesh out a little bit the mechanisms for interoperability through the data namespace. So that's all I have, and I'm gonna try to open it to questions now. Go back to an earlier slide while we're doing that. And those questions, I think, are best asked in one of the two chats that are open. So there's a group chat in a Google Hangout that I think I'm the only one left in. Then there's a GChat window that I think most people are in. If you don't have the GChat window, I don't know what to do to get you there. So maybe somebody can put a link for that GChat into the Hangout, or tell me what to do to get that to people. But that's all that I have, and so now I think we're going to see exactly how long the delay is, and I'll wait to see what some of the questions are. I guess for anybody that's watching later, the delay is pretty long, so I'm going to go ahead and record the answers. But it may take a moment for the questions to come in. So anyway, hang tight if you're watching this and you want to see what the questions are. For those of you that are on the live broadcast, I think I am going to just answer the questions in both chat and verbally, so the folks on the chat window don't have to wait around. But I'll try to answer them verbally too, as well as I type. So there's a question about encrypted keys and what key are they encrypted with. I'm going to move back to the slide that's corresponding to that, I think, if I can, and try to then also answer it in the chat. So the question is, what key are they encrypted with? My assumption is that either intermediate processing components or the final visualization components are, they need to be granted access by the publisher to the data that they need. And that data, and that may be done by either giving them access to a pre-existing symmetric key, or, for example, that's been used to encrypt a certain amount of data, or to encrypt that data anew and provide access to it using a new key. That second approach would probably require more a different namespace than what's shown. And so the question of what key are they encrypted with, my assumption is that they were encrypted with a key that could be, for example, the public key of a service or a consumer that needs to get access to the data, or a group that corresponds to a group of consumers that would have access. So I'm going to try to now type that answer. While I'm waiting for other questions, I'll go ahead and record the answer that I wrote in the chat. My assumption is that the publisher will have to grant access to the subsets of data needed by the consumer, either processing blocks or visualizations in the schemes shown. That access would be given by using the consuming applications or a corresponding group of applications to encrypt a symmetric key, as one example, public key. We were able to come up with a scheme in Wen-Tao's work that did this by placing encrypted keys in NDN connected storage rather than envisioning it as an interactive key exchange service. I hope something similar could be done again here. The challenge is deciding what process grants access and publishes the necessary keys. For now, it's the personal data repository blocks of these functions these are functions that it does beyond that of a basic repo. Okay, I'm going to continue recording the questions, though I can't imagine that anybody else is here at this point in the live recording. So Wen-Tao asks, will there be any kind of group communication or sharing in mHealth, or will the data be private just to a small number of users or accessible to a large number? So this is a really good question. The reason that we've included some ambiguous group exercising functionality in the app description is to propose that some sharing of data among user groups is desirable and motivated with the use case. Whether that translates to direct access to the repositories isn't clear. Could just be done at the visualization application side. There are also plenty of cases, for example, genome-wide association studies in genomics, where access to anonymous, or emphasis on the quotes here for anonymous, data across a wide population is also very useful. We are not emphasizing that here, as it introduces complications beyond sharing just with the friend groups. So I'm going to wrap up and return to a title slide here for anybody that's still watching, and stop the broadcast as I need to go to another meeting.